Hi, I'm going to have a hands-on look at how to make custom indicators for market data. Now, for some markets, you don't need an indicator because the trend in the market is quite obvious to see. However, for other markets, an indicator can help you make buy or sell decisions. Now, the main library that I'm going to be working with is mplfinance, which is a Python project for working with financial market data. So this library builds on top of the matplotlib and pandas libraries, and it allows you to easily work with Candlestick data. Here's some examples of the plots in the README file. So if we clone the library, we can start having a look at the ins and outs of the project. Within the project, there is a wealth of examples to have a look at and build upon. We've got some basic indicators here. We've got the Ichimoku cloud, the MACD, and the RSI. So the mplfinance library has some slight differences to the underlying matplotlib library, so it's important that you look at the examples and then build upon the examples to achieve what you want to achieve. So if we open up some of the example notebooks, we can see how to start working with the library. So here's the golden cross. One interesting thing to do with the library is to work with animations. So they've got a few example animations to look at and build on, because especially when you're working with large data sets, you cannot properly visualize that in a single plot. Let me just run this example animation. So working from this MACD example animation, I'm going to build on top of it so that I can then start using exotic custom market indicators. So the next key thing is we actually need some market data, some open and close values and volume values for a market pair. Now, a simple way of obtaining some market data is using the custodian centralized crypto marketplace Binance. So there is a Python project, Binance-Klines, which can be used to retrieve candlestick data for a market pair. So we need start date, we need the time frame, and a market pair. And this is the retrieve data. So I started out by modifying the animation example in the mplfinance example folder. So if we go down to the animate function, we see that each animation frame, it's creating the plot data, clearing the axis, and then redrawing the plot. So same as before, I'm clearing the axis and redrawing the plot. The difference is that I'm pulling out a subset of the data. I'm slicing the data frame as per a window size, and then I'm passing that over to my function that is then plotting it. So then if I call this, I've got a plot of the data within a set time frame. Moving on, I set about making some custom exotic market indicators. Here is my interface for my indicators. I've got a function to get the plot data. So the key for the data, the marker, and the color, which is then used by the mplfinance library. Then I've got a prep function, which merely, in my examples, are merely filling the data with not a number values. And then I've got a work function which adds the relevant indicator data to the data frame that is passed to it. The first novel indicator that I put together was one based on the full moon. So whenever there's a new moon, I'm going to be buying. Whenever there's a full moon, I'm going to be selling. And I got my data from the US Navy. So here's my keys. So a full moon will be indicated by a circle and a red, and a new moon is indicated by an X. And then in my work function, what I'm doing is merely working out if there is a full moon or a new moon at the specific date at the pointer in the data set that we have. Then if it's a full moon or a new moon, I'm adding a marker to the data frame, which will then get plotted by the mplfinance library thanks to this in my animation function. So let me run this. Here we are, we've got indication of the full moon and the new moons being added to the data plots. I'll just run a quick simulation of this to see if it will actually make any money. So here we are, we've got the first trade and the end trade. So with the first trade we ended up with 26 BNB, and with our end trade we've got less than 3 BNB. So well, we didn't lose money, but we would have made more money if we simply held. Not being happy with how stupid a lunar cycle trading indicator was, I decided to make another indicator, this one based on Pythagorean numerology. So I've got a indicator class for Pythagorean numerology. So apparently you can have a life path number based on your date of birth, and then you can check whether or not a date is compatible with your life path number or not. So I've got a function, is date time compatible with life path number? So in my work function, I'm working out whether or not the date time string of the candlestick data is compatible with my life path number. If it is compatible, I'm going to do a buy. If it's not compatible, I'm going to do a sell. So let's see what this Pythagorean numerology indicator looks like in practice and whether or not you can make money on it. It definitely doesn't look like it's a practical indicator. We've got buys and sells all over the place. But let me just run a quick simulation to see if it actually loses money or makes money. Okay, so actually better than the lunar cycle indicator. I started out trading with $1,000 and we ended up with $5,800, but same as before, because of the large price increase of BNB in this time period, it would have been better simply to hold and not do any trades, but there we are. These obviously aren't very practical examples, but it points out that you can pretty much make any indicator you can think up. So for example, you could do sentiment analysis on a news feed for a certain market and then use that to make a buy or sell decision. So in conclusion, working with market data locally enables you to try out some quite exotic market indicator ideas, and the mplfinance library enables you to visualize these ideas so that you can quite quickly tell whether or not they are viable or not. Now, I would recommend people trying it out for themselves and see what happens.